Hi guys, so today's lecture will be about enhanced for loops, also known as for each loops, as well as iterators, and how those two subjects relate to each other and relate to collections, or also data structures. So if we look at the slides, I pose a question. How do we loop through the elements in a collection? More specifically, looking at the data structures that we already know about, a linked list, an array list, a stack, and a queue, how do we traverse through all of the data within those data structures if we are from the perspective of using that data structure? So, a naive approach might be to use the toArray method, like we've previously used and talked about in class, and traverse through the elements as you would any normal array by indexing, successive elements, using the array returned from the toArray method. But this is actually a naive approach. There's a better option. And so the answer is you can use an enhanced for loop. And this is also known as a for each loop. And you'll see why in a second here. So, given some array list of strings, we're going to call this array list book titles. Here's an example of an enhanced for loop. Notice we start off with the for syntax, but then after that, the syntax changes from the standard for loop that you're used to. It's missing the int, I equals 0, I is less than some value, I++, or however many different variations of the standard for loop you like to use. This syntax is different. You'll notice we're declaring a string here, which is because the book titles array list is an array list of strings. We declare a variable, we call it book title. Notice this is just a single book title. It's missing the S, which our array list of strings has the S, right? Colon, book titles. And so this book titles here is indeed the array list of strings that we're talking about up here. And then within the for loop, what we do is we print book title, the variable here. And so this is some interesting syntax here, right? We really haven't worked with this before. Some of you might already know about this. But what it's doing is, what it's saying is, for each string or book title, inside of our book titles array list, I'm going to print that book title. And so yeah, one way to think of the enhanced for loop is for each element in a data structure, you're going to do something. In our case, we were just printing the value. And so for example, using the previous example, you could say for each book title in a collection of book titles, print the book title. And so yeah, this is just showing the same example as before, the same enhanced for loop for each book title in book titles. And so yeah, notice the unique for loop syntax. We declare a variable called book title of type string. Once again, it's of type string because book titles is an array list of strings. If for some reason book titles was an array list of integers, then in this case the type would be integer. If book titles was an array list of booleans, book title would then be a boolean. And so yeah, we declare this variable book title. We place this colon, which is interesting syntax, right? You can think of the colon as kind of like in. So you could say for each book title that is of type string in this collection of strings called book titles, print the book title. And so the enhanced for loop declares a new variable that will be assigned with each successive element of a container object or a collection such as an array or an array list. And this brings up a good point. You can actually use this enhanced for loop syntax with arrays as well, just standard arrays. So I'll go ahead and show a quick example. I'll go ahead and go to my IDE for this. So here you can see I just have a public class main. I'll go ahead and give it the main method, public static void main string array args. And the first thing I'm going to do is test that my application is currently running as it should. Print hello world and run it for the very first time. Run. Main. And we look and it ran correctly. Good. So what I want to do here is I'm going to go ahead and create an array list. Just to show you something different, I'll do an array list of, we'll do integers. I'll call this, it says I need to import the java.util.arraylist, so I'll go ahead and do that. So we'll go ahead and just call this, I don't know, array list equals new array list. There we go, we now have an array list. Now we need to add some things to our array list, so we'll say array list dot add. We'll go ahead, I don't know, let's just add some random number of elements. So here you can see we have 4 elements, I don't know. There you go, we have some random integers in here. And what I'm going to do is I'm going to sequentially iterate or access each one of those elements in my array list data structure. And so this is what I was talking about when I was saying from the perspective of using the data structure, we're using this array list. And so we'll go ahead and use that enhanced for loop. So for each integer, right, it's an integer because it's going to be an array list of integers. We'll go ahead and call this number. To shorten this, we'll just call it num. So for each num, or number, that is an integer in a collection of integers called array list, array list, what I want to do is print the number. So we'll go ahead and see if this works. And there you go. 5, 1, 2, 3, 4, 3, 4, 5, and 7, 6. And so we successfully added or accessed the elements within our array list. And this can prove useful for any number of reasons, right? We could have taken each of these numbers and done some mathematical calculations or things of that nature. So going back to the slides, an enhanced for loop increases readability of code as well as provides a nice level of convenience when working with data structures. So yeah, the readability is very easy, right? Once you understand what the syntax means, it's very easy to tell, oh, okay, so what you're saying is we're going to get one element at a time from this data structure, each of its pieces of data, or each of its elements. And it is very convenient. It's much easier than using that toArray method and then using the standard for loop where you use, you index into an array repeatedly and access the elements there. So I pose another question. If you make your own data structure, does this mean anyone using your data structure can therefore use an enhanced for loop on it? Now this is assuming your data structure doesn't implement Java's collection interface. So the answer is no. And the reason being is the enhanced for loop is syntactic sugar for using something called an iterator. And the enhanced for loop can only be used with those data structures that implement the iterable interface. And so we're learning two new terms here, an iterator and iterable interface. And they sound very similar, and they are very closely related, but they are distinctly different. And so please pay attention to the minute differences between the two. The iterator is an interface that belongs to Java's collection framework, and it allows us to travel the collection and access each of its data elements. It does this by supplying three methods, and we're going to look at two of them, the hasNext and the next method. Now the third method is called remove, and it's not really used, and so we're not really going to go over it. So what are these methods doing? Well, the hasNext, it returns true if the iterator has more elements to iterate through. The next method returns the next method or next element in the collection until the hasNext method eventually returns false. This method throws a no such element exception if there is no next element. This will be made more clear why it's doing this in a second here. So to look at this a little more abstractly, we'll go ahead and look at the board here. Let's say I have an array list, and I'm going to represent it just using a standard array by just drawing a bunch of cells. And so in this case, right, I'm only going to have, let's say, 5, 3, 7, 15. So this, we could say my array list of integers, right, is just being represented by these cells here. Now, if we're looking at the hasNext and the next, you need to think of it in terms of looping, right? So for each loop in a for loop, you're going to call a hasNext method and a next method. And so if we're looping at the very beginning of the loop, we start at the very first element. Draw a better arrow than that. There we go. And so the question we ask ourselves is, okay, does hasNext return true? Do we have another element that can be looked at using our iterator? And the answer is, of course, yes. Right? We have this 5. And so in the same loop, we would then call the next method. And the next method would then return 5. It doesn't return all of the elements. It only returns the next available element to be returned. And then so the loop continues, and we're no longer going to look at the 5. We'll look at the 3. And the hasNext method will then say, okay, is there another element to be returned? The answer is yes. And so the next method will then return the 3. And we continue on with the loop, okay. hasNext returns true, there's still another element to be returned. And so next would then return the 7. And then the loop continues. hasNext, of course, returns true again. And so the next method will return the 15. And then the loop continues, and you'll notice that we're at the end of our array. There's nothing else to return. And so the hasNext method will return false right here, right? There's nothing else to return, and so we're done. And so abstractly, you can think of the iterator as working like this. And you'll notice we've accessed all of the elements within our array list. So going back to the slides, this is just what the interface looks like, the iterator interface. You'll notice it uses the Java generics. And so yeah, the hasNext method is just returning a Boolean. Is there another element available? If there is, then we use the next method, which will return that element. Notice it's just returning it, it's not actually removing it. It's more so a get method. And then there's the remove method, but again, we're not going to really worry about that. So Java's collection implements the iterable interface, not the iterator interface. And so what's the difference? And the difference is the iterable interface specifies a method called iterator. And that returns an iterator object. It is this interface that allows an enhanced for loop to be used on a collection. And so the iterator interface is what specifies the hasNext and next methods, and then these are the methods that are responsible for the traversal over the data inside of a collection. So it says, let's look at Java's documentation, but really I want to go to our IDE. So what we're going to do here is we're going to make our own little data structure. And our data structure, it's going to be very rudimentary, but the main purpose of it is going to be adding elements and then using an iterator to iterate through those elements. So I'm going to go ahead and go to source here, create a file, call it my collection class. There we go. We're going to use Java generics here. So our collection or data structure will deal with some type E. We don't know what that is yet. Now, to start off, before we get to the iterator stuff, let's kind of get started on our data structure here. I want our data structure the underlying data structure to be, we'll go ahead and make it an array list. Array list of type E. I'll go ahead and import the array list here. And we'll call this our elements. Cool. And that's probably good. We'll go ahead and create a constructor. So constructor public my collection class. We'll make the elements private here. And our constructor, all it's going to do is create or instantiate an array list object and set it equal to elements. Okay, so that's good. And then I want to create an add method. So public void add e element. So element is what we're adding into our data structure here. And in our case, we're going to use the add method for our array list. So add element. Okay, so this is good. Now what we want to do is we want to add in our iterable interface in order to use an enhanced for loop on our myCollection class data structure. So what we do here is we implement iterable. That's the one we want. We give it the type E, the generic type. Now it's getting mad at us. It says class, my collection class, must either be declared abstract or implement abstract method iterator in iterable. All that's saying, right, is that iterable is an interface and you haven't implemented the appropriate methods. So we'll go ahead and click implement methods. You'll see multiple methods here. The only one we really need is iterator. So click OK. There we go. So we now have the appropriate method that will allow us to use an enhanced for loop on our myCollection class data structure. Now, of course, this iterator method isn't doing anything. It's just returning null. So now we want to be able to make it do something. And the idea here is, there's many different ways to do this. One way is you can create an inner class and have that inner class, we could call it like my iterator, and then it would implement the iterator interface, in other words, that has next and next methods. But another way we can do this is by having our class itself implement the iterator interface. So iterator, and this will also take in the Java generics. Now it's going to get mad at us for the same reason. It says class, my collection class, must either be declared abstract or implement abstract method has next in iterator. All that's saying, once again, is we have not implemented the appropriate methods, in other words, has next and next. Now, the question is, how are we going to determine which element we're on inside of our data structure? In other words, right, if we look back at this example, we had an arrow pointing to what? Each index inside of our array here. And so that's actually what we want. We want an index that's going to help us traverse through the elements in our array list. So we'll call this iter index. And this iter index, we'll go ahead and initialize it to 0. So iter index equals 0. Okay, and so now what we want it to do is we want to use our iter index in conjunction with the number of elements, which we could use the size method. And this will determine if there's another element available, right? For example, if iter index, if we look at the board here, go ahead and erase this. If iter index starts at 0, it's referencing this element, right? We'll put iter index. Right, currently it's 0. And the size is currently 4, right? So size equals 4, iter index equals 0. So we're trying to figure out what conditions will, using these two variables, return the appropriate value in our hasNext method. And so if we call hasNext while currently referencing this spot in our array, it should return true. And so you might be able to see this. For as long as our iter index is less than the size, then our condition holds true. So this is what we're looking at here. Iter index is less than size. Well, let's see if this holds true. So iter index is 0, it's less than the size, and our has next should return true. Good. We move on. Iter index gets incremented. It now references the next element. Iter index is still less than the size, which means our has next should return true. Good. And this will hold true for the next one. Iter index is 3. I'm sorry, 2. And then the one after that, 3, this will hold true. But now the moment iter index becomes 4, this Boolean expression here is no longer true and will return false. Which is what we want. We want has next to return false when we reach this circumstance. So what does this look like programmatically? Well, it's actually quite simple. We're just going to use that Boolean expression. So iter index is less than elements dot size. And there we go. So and this will be sufficient, right? This is basically going to return true as long as there's a next element available, and then eventually return false when there is no longer an element accessible to our iterator. Now the question becomes, okay, currently iter index is stuck at 0. We need to increment it. And where do we increment it? Well, we increment it in our next variable, which should be getting the next available element based on our iter index variable. So I'm going to go ahead and write an if statement. So if not has next, throw new, no such, close, element exception. So basically, once the has next, if it ever fails, then there's no element available, and we're going to throw this exception. Why do we need to do this? Well, it's built into the for loop, that syntactic sugar, the enhanced for loop. It's expecting eventually a no such element exception to be thrown. That's how it knows it's reached the end of the end of the collection, the end of the data. Why they chose that, I don't know. So, but if has next does indeed return true, then we know there's still an element available to be returned, and so what we want to do is return elements dot get at a particular index. We want iter index, and this will get us the appropriate element. Okay, and so now what do we need to do? Well, we have our has next, and we have our next method, and what we really need to do is return an iterator. Well, if you look, we've specified ourself, the collection class, to be an iterator. And so what we're going to do is actually return ourself. So this. Now we're missing one more thing. If you notice, this will only work if we call our iterator method one time. Oh, I'm sorry, we're missing something. We need to increment the iter index. So we'll add a plus plus there. And so this is what's going to increment the iterator index, allowing us to access sequentially each element. Now, what I was saying before is our iterator method as it stands will only work once. That's because right now as it stands, once we're done with one iterator, the iter index does not get reset back to 0 as it should. And so that's what we need to add here in our iterator method. Iter index is equal to 0. There we go. So now what we can do is check and see if everything we've implemented will work appropriately. So I'm going to, instead of having an array list here, we'll call it my collection class. My CC, that's what I'll call it. And I can do this fancy thing if I can figure out how to do this. Refactor, rename, my CC, cool. Just some fancy IDE stuff there. And so now what you can see, right, is here's my collection class. I specified the generic type to be integer. And then I'm going to add some integers. So 5, 1, 2, 3, 4, 3, 4, 5, 76. And now notice we can use the enhanced for loop. Just to show you that we can only use it because of those interfaces that we've implemented, I'm going to comment out these methods. And I'll go ahead and comment out the interfaces here that we implemented. And coming back here to the main method, you'll notice we have an error. It says for each, not applicable to type my collection class, and then the angle brackets, java.lang.integer. And so basically what that's saying is, hey, you do not implement the iterable interface. Therefore, you cannot be used inside of this for each loop. So we'll go ahead and come back and get rid of those comments. Okay, so let's go ahead and run it and see if it runs exactly as we expect it to. And there you go. And so now we've appropriately implemented the iterable interface as well as the iterator interface in conjunction. Now, you might be wondering, okay, we're using this array list as our underlying data structure here. Why wouldn't we just use the array list iterator? And that's true. We totally could have done that. But I've used the array list data structure here to avoid some complexities that would have taken away from showing the idea behind using an iterator. In reality, you might, and what you'll probably notice in your midterm, is that actually what you might use is an array of generic types E, in which case then, yeah, you wouldn't be able to use the iterator method available to you. You would have to implement it yourself, as we did in this case here. Okay, going back to the slides. So looking back at the enhanced for each loops, this is what we just used, right? In this case, we used a string here, my collection, for each string in my collection class, I print the string. Now that's syntactic sugar for the following. Iterator of type string iter equals my collection class dot iterator, and then while my iter dot has next, print iter dot next. So this is the calling the actual methods, the has next, the next. All of this is done for us inside of the enhanced for loop, or these for each loops. This is why, its readability is increased and its ease of use is increased, because we no longer have to worry about these method calls or even the iterator interface at all, really. And just to show you that it does indeed work like this, we'll go back to our IDE and look at our own example here. I'm going to comment out this for loop here. And what we'll do is we'll create an iterator object, specify type integer, we'll call it iter, is equal to mycc.iterator. And then what we want to do is while iter.hasNext. So while there's a variable or an element available still in the data structure, we want to system.out.println the next piece of data or element. And so we'll call the next. And just to show that this does indeed work as we expect it to, we'll run it. And there you go. It does indeed work exactly as we expect it to. And that will conclude this lecture for enhanced for loops and iterators.